of hands over here. Who is ready to learn about Cassandra today? There you go. So before we get in here, I'm going to get my guys here from DataStax, got Darshan Wall and Mark Cromer, and we'll let you guys take stage on that.
Thanks, Arjit. So, first of all, thank you everyone, and welcome. I don't know about you guys, but this is pretty overwhelming, what's going on. Any of you have been to, any one of you or two of you have been to a 2011 conference when you were there? Anyone? Amazing, right? Yeah, there was in 2011 and 2012, and we had 145 people. So it's pretty amazing to see this many folks show up in the audience. So what we're gonna do today is me and Mark, we are in the product management team of DataStax, and I have been here for about 2 years, been a customer for DataStax for about 2 years before that. So I've seen all the good, bad, and ugly of Cassandra, but it's something that has evolved over the years, and there is this notion of a multi-model platform that is brewing in the NoSQL community. The question is, what the hell is it exactly, right? Going beyond the theory of what it really is, this is going to be a more product-specific, realistic, down to the top. By the way, both me and Mark are fairly technical, so I'm an engineer at heart. When I do get time, I code, not just the PowerPoint. But if you have any technical questions, feel free to ask it as after the talk. This will be it. All right, so let's define multi-models first, because I think that itself is a huge confusion area right now for most folks. We'll look at the evolution of models, what do we mean by different models, and then Mark will dwell very deep into graph databases, the open source part of it, and the DataStax part of it, and kind of lay out from a product perspective what you can expect in the AC graph, and manage it and conclude. So let's define multi-model. I took this code from Wikipedia, no surprises there, and then you can read through it. I don't want to repeat it verbatim, but the key thing is that in the old world there was a single model which defined how data was stored, organized, and accessed. In the new world, there are multiple data models, but the last part, which is actually the key, which many folks forget, is it's actually those multiple models work against a single integrated backend. And I think that last piece people forget. They start talking about multi-models, but they focus about the last piece because, and I'll show you in a moment why that is important. So let's look at models. You had this very fine, nice model architecture in the RDBMS world. You had structured query language. You had an RDBMS which was actually implementing the SQL standard, SQL 92, 99, whatever it was. You had a very cohesive set of drivers, obviously given SQL is 25 years old or whatnot. And then you wrote your application on top of it. Perfect, life was perfect. Then the early part of the NoSQL movement started with, well, you should really use the right model for your right use case. You should not try to overload the SQL with a variety of use cases. And there was some value in it. That's another reason why we are all here after 5 years of the NoSQL movement. But what ended up happening was that each of these multiple models started creating their own persistent mechanisms, right? So you actually had key-value stores implemented their own way, a document database do it their own way, and a graph databases do it their own way. And this is still all right if you have siloed applications which are actually accessing just graph or document or key-value pair. The next thing that was a problem though, the access mechanisms for these different models were very different. In fact, what I'm trying to show here is that the languages in which these drivers are implemented are also varied. And if you look at a document database, they'll implement Node.js and Go because that's the hacky crowd that want to use document databases. If you look at someone like us, we'll implement C++ and Java and pour enterprise-ready drivers. And then if you look at graph, it's so nascent that there are very few drivers available out there. But fundamentally, these are very different drivers. You have to work through each one of them independently. So what would you do? Anybody heard about this word, which we have been doing for, I don't know, 25 years now? We all start writing data access objects or data abstraction layers and whatnot, because guess what? I don't have time to figure out what languages to use and whatnot, and I have to start shielding stuff. And if it was a standard, it's easy, but if it's not a standard, then it makes it even more harder. People used to do this in RDBMS world too, but just to abstract between, I can theoretically switch between a MySQL and an Oracle because it's all SQL, or that was the myth. And your application was written on top of it so that everything was hunky-dory until it was not. This is actually a nightmare if you really start thinking about it. Because if you just start from the bottom, you actually are talking about data movement and atomicity issues at a very persistent layer. You're actually having to move data if your application needs at least 2 of these models. And as applications are evolving, they're starting to realize key value was great for quick lookups, but I really want to know if I'm doing fraud protection, some kind of graph modeling. And I'm not talking of kind of large-scale graph exploration, but I'm actually talking of you have a use case where you do a fingerprint, a big government agency in Europe, without talking names, they want to figure out human trafficking. They want to do biometric lookup very quickly, 250 millisecond or less. If it actually gives you a false positive ratio of something high, meaning this person looks like being trafficked, then they want to do a much more deeper analysis, which can take up to 10 seconds, and that would be a graph query or a traversal, if you will. And they want to do all of this in the same application. I mean, this is real. So if you start thinking for a moment, the admin is pretty upset because now you're moving data around and he has to learn how to manage these databases. The developer is actually pretty upset because he needs to figure out what is the lowest common denominator across all these languages and such. And it just is a nightmare, both from development and administration perspective. So let's look at these two and then say, so what would multi-model look like? So there's definitely value in saying that you should use the right model for your right access pattern, right? I mean, if you're doing a lookup, key value makes sense. If you're doing a traverse, then probably a graph makes sense. If you have unstructured data and you want to throw anything at it, maybe a JSON document sort of makes sense, right? But then you do not need, these are logical models. At a physical layer, you do not need to bear the cost of, hey, my graph database is not georedundant, but my key value is because I'm using Cassandra. By the way, my document databases are running master slave, which is what many of the document databases do. You need a common physical semantics for the admin, operations, and all of that good stuff. But more importantly, if this vision actually gets realized, then the access mechanisms become much more standardized, normalized, whatever you want to call it. Now, I want to caution people starting to think that, oh, I have the same key value semantics and I'm going to start running a graph language on it. That's not what this really means. What this means is that from an application perspective, they get a common vocabulary of doing a graph query and also doing a key lookup, whether it's the same languages or the same set of drivers or whatnot. These queries will be different, obviously, because they are different. But fundamentally, you get the common tool chain, if you will, for your application. So the development productivity goes high. And finally, you write your application on top of it, hopefully. And again, this is an utopia if this ever happens. I have not seen it in, I don't know, if you folks have been around that from 1990s to now, everybody still keeps on writing data access objects. Doesn't matter where you go. But what's key over there is that you can actually run a transactional or an analytical workload on this multiple models. And I think that's key because these barriers of, in fact, we were talking at one, we should talk about analytics in depth. This notion of an operational database and the notion that it's actually also going to do near real-time analytics, streaming analytics, fast feedback loops, is starting to emerge. Where it used to be, OLAP was your backend system, Teradata, IBM, whatever. It's your internal system. You don't really care too much about it from a resiliency perspective. And transactions are very important. They're the holy grail. Don't touch it. Don't bring it down. Turns out these two systems are kind of starting to merge because of this fast feedback loops. And you want to allow that multi-workload to run on that common multi-model platform. And that's what, at least I believe, is a multi-model kind of approach that folks should take. So without going into the religious battle, you have essentially a multi-model which is empirically learning from the industry evolution that has been there for quite some time. So let's define that one more time. You might call it polyglot models or multi-models or whatever, but the most important part is it should provide a cohesive interaction mechanism for whom? For developers, for application developers, because they don't want to run around saying, I want to write this layer in Node.js and that layer in Java, and this vendor is doing this and otherwise there is not. It should work for both kinds of workloads, OLTP and OLAP. It should have unified persistence, or what I call physical layer characteristics. This is fundamentally very important. You cannot have, in this new world, one model being redundant and the other not. And data movement should be as minimized as possible. Otherwise, you start implementing anything else. You'll dump from one system and put it into another. This is what happens today. It should give you the geo-redundant always-on characteristics because these are necessary in today's systems. This is not something that you can live with. Finally, it should be TCO efficient, because if you remember my polyglot persistent model, one could argue that, yeah, sure, that's also multi-model in many ways. The question is, what is the operational overhead and what is the capex and the opex that we need to worry about? And the last part is very important, which is for a variety of use cases. And there are people who do graph very well for, let's say, fraud, but they will suck at trying to do it for recommendation engines and playlists and personalization and stuff. Or they'll do key value very well for Internet of Things because they're just ingesting data, but then they cannot find relations in some of these things. So how do you get a database platform which is allowing you all these characteristics in an operational backbone like Cassandra in a single platform? That's the vision for DAC multi-model. Okay? So let's look at, let's get a little deeper. Right? So now we'll talk about three key pivots of this. And again, not all multi-model platforms are going to be equal. People will create different things. I'll show you how different our JSON stuff is compared to other folks. But we just announced this thing called materialized views in Cassandra for a moment, right? So what does it really boil down to? And I've hyper-simplified this for folks. But what you look at is, let's say you have a simple table with a primary key and a bunch of columns. And you create a materialized view, maybe time ordered or however, some partition key. And you say MV1 is for column 1 and MV2 is for column 2. Right? This is standard materialized view. So that when I do a write into or an insert into this table, I get my MVs populated. Table stakes. This is what RDBMSs do. This was what Cassandra was telling folks to do for 5 years. In the notion of denormalization. Application code had to do this. If you ever wrote an application, they'll tell you, basically optimize this for your query patterns. And these MVs are optimized for sequential access on the disk for query patterns. And that's okay, but you still are accessing almost the same amount of data because the number of cells here and the number of cells there are great. One unique thing though, what John can announce is that the storage cost savings of this will be pretty dramatic because of the things that are coming in Cassandra 3.0, because we will not store, will not occupy the 4 bytes that you should occupy, but we'll try to occupy deltas between different values and incremental values. And where these use cases start mattering is if you have a temperature sensor which is actually sending you sensor data, your temperature sensor is not going to go from 25.3 to 256. It's probably going to go from 25.3 to 27.8 or something of that sort. So that's kind of one notion. The next one, which is actually going to be more important, is how do you create aggregates on this, right? Let's say I want to create an average of this value. Now, this is where it gets really interesting because many times applications are actually sucking all these columns out and saying, give me an average of this temperature and throwing away all the data. It's pretty inefficient use of network resources and JVM and all that other good stuff. So you're actually going to get these aggregates over here too. Now, remember, all of this was happening with users of Cassandra for 5 years. It is not something new. What's new is that the database is actually providing a logical construct for you and not leaving you to the wild of the physical realities. Right? And that's what is pretty dramatic. And in providing you the consistency guarantees, providing you the atomicity guarantees, providing you and ensuring that when you really insert here, something gets inserted here. These are not non-trivial problems in a distributed system, especially if you don't have a log manager. So this is a pretty fundamental move for us where instead of remaining at the physical layer, you're starting to talk about white rows and materialized views, which is a logical construct, which is very powerful from a development perspective. So that's what you get in terms of white rows and MVs. The next is JSON. Remember, I didn't use the word document here because I think that's extremely misleading because of the way industry has defined it. First of all, that word itself is pretty interesting. But what we did was we said we implemented something called JSON in Cassandra 2.2 and also Cassandra 3.0, which will include it. What happens is, and then we covered this in the keynote, but basically you just enter this keyword called JSON into your insert or select statements, and you essentially get JSON in and out. It's as simple as that. But I think what's unique and what most people don't do is something of this sort. So this code snippets I'm showing is from like our developer tool, which is Dev Center, which is actually using the Cassandra query language to access this. You are writing a query. While you actually wrote the query, it has already figured out that the value that you're entering here is incompatible with the backend schema. And this is unique. So this is something that a lot of document databases cannot do because, quote unquote, they are schema free or whatever you want to call it. But because we are aware of the schema, the client application already knows of the query problem before the query is executed. Now this might seem trivial if it's a development tool, but imagine if your upstream system introduced a bug and threw in some data, and you actually had to work through this. That data will get sucked in a schema-free system. In our system, it will get rejected. And this was a very conscious choice that we made because we said we want to become the enterprise platform. We're not interested in the hacky startup crowd, throw anything at me, plain JSON key value pairs at me. You can still do it because we have key value pair support. So if you really want to throw arbitrary data, you can do it. But fundamentally, we want to be aware of the schema because it gives us this kind of capabilities which other folks do not do. That's another key reason why we said we don't want to call ourselves document, but we want to call ourselves JSON. And if you see for a moment, this JSON structure till 2.1 was using, it uses UDTs, user-defined types in Cassandra, where, for example, this person is a UDT that you define. And if you remove the word JSON, you can access it in CQL. If you put JSON, it's just JSON, right? The genius of this is that, let's say I want to update street of this field. The way it used to work, the way it works in most document databases, because there's schemaless or whatever you want to call them, is that they will read the whole block, this whole person object. They'll figure out where that offset is for that address. They'll change that address and write the whole block back. If you are a systems guy, you'll pull your hair because if it's a 10K block and you're updating 5 bytes, you're paying the cost of 10K. So the more nesting that the JSON gets, which is what it is going, you start paying huge amounts of cost in terms of I/O.
So they can indent.
Yeah, for taking indent, sure. But again, it's a question of how easy it is to manage those schemas, right? So, but the key was, so when you talk to enterprise customers, they say, we don't care what is really appealing to us about JSON. A is the message exchange format, like XML was 15 years ago. But the second thing that is important to us is that when things change, we want to make that change easy. So because Cassandra is designed the way it is designed, changing a schema is an O1 operation. It is not an ON operation. And that's a fundamental mind shift that people don't get. That one feature actually gives enterprises 85% of the value of what they like to call schema-less databases, right?
It's less brittle.
It's less brittle, exactly. It's less brittle, that's rightfully put.
Isn't your this collection thing similar to the concept of compile queries in relation databases?
Very similar, very similar. So that's another reason why we want to focus on the driver code the driver is aware of the schema in the cluster. If you actually look at our drivers are not just aware of the static information like schema and set, but it's also aware of the cluster information. So it will figure out all these errors on the client side before you even fire the query. And this happens in your applications live. This is not sent to the server, they detect an error, and then you throw the error back. Yeah. So I covered white row and multiply views, and I covered JSON, and now Mark is going to deep dive into React.
Okay, next session. So it seems like it's a bit of a leap, but it's actually a continuation. So the whole concept of what we're trying to get across here, again, to just kind of recap real quickly, is this idea of DataStax providing an enterprise-ready data platform that enables multiple logical modeling capabilities for you. And so one of the new things that we're introducing, and I should say that DataStax from an enterprise software perspective, we don't have our graph database in the market yet. We have, was anybody here over at the Titan 1.0 speech just before, session before this one? So we have some people interested in graphs. So Titan 1.0, Titan is the open source graph that DataStax is represented with by the Aurelius team that was acquired. They put that out there. So let me sort of explain to you where we're going and some of the differences there, and how this enables that multi-model idea, even a little bit further than the difference between inserting data via JSON or SQL or whatever you do there for tables. The idea here that we want to do with a graph database is, this is just sort of generic graph database sort of 101 things for those of you who are a little bit new to graph databases. And just to step back for a second too, like Darshan said, is that at DataStax, I'm the product manager responsible for graph. So this is what I focus on day in and day out, is building, working with the engineering team and our developers to build our graph database, take it to market and be successful with that. And we want to couch it within this idea of multi-model so that we wouldn't say to anybody developing an application on DataStax to say that all we offer you is a graph model, or all we offer you is SQL or whatever it may be. It's options, decision points that you'll have when you're building your application of what fits best. And the idea of a graph is just that idea of, pretty simple if you think about it, right? It's the idea of having nodes or vertices and they're connected. Essentially what you're looking at is a directed graph. So it's having relationships that are called edges, and those are stored in a data store somewhere, and of course with DataStax, that's all stored within Cassandra. So there's no, at the end of the day, we don't have a separate data store or graph, it's all using Cassandra. The way you model your data and the way you query it is going to be through a different mechanism, which I'll introduce to you if you haven't seen it before. And hopefully I think I had all those bullet points I have up there. The last one is an interesting one. If you're trying to get just starting to get your mind around what a graph database is and does, and the difference between that and other NoSQL sort of approaches. The idea is that a graph can be seen as a pre-joined database. And I like to use that for folks who are new to, or they're coming from RDBMS world, and they have a lot of third normal form, a lot of complex joins in their applications. And the idea behind a graph is that the relationships between the data are first-class citizens in your data model. And so when you put those things side by side, you look at what you get with DataStax, which is Cassandra, and which is, let me not say Cassandra because it's all stored in Cassandra at the end of the day, but what you get is a tabular-based model versus a graph model. And you think about the fact that you may have an application that fits really well within some of the modeling the logical modeling that Darshan just laid out for you. And that's the classic Cassandra data modeling. If you have that sort of data that is very highly connected, needs to have a lot of relationships that are built into the data because you have a lot of complex joins in your app, and you're maybe finding it difficult to denormalize that with a query first based sort of modeling approach, then graph might be a good option for you. And we're going to provide that as well for you when we have this in market. So I think I hit on a lot of those ideas. If you want to think about sort of what is a good use case for graph versus playing Cassandra and SQL, I'm going to actually say that because I do have some examples in the slides. But what we put in the slide was the ideas of things like social engagement models, recommendation engines, IT network device management. And I'll be honest with you, a lot of those can be solved with other technologies or with Cassandra natively, but it may fit better. It may be easier to manage that in a graph, right? Because it might be easier for you to visualize it, to change it on the fly. The idea behind our property graph approach is that it's a flexible schema. So let me kind of dive into that a little bit more. What we're building with DataStax Graph is based upon the learnings from Titan. So those of you who have played with Titan or used Titan or have seen it in the past, the same engineering team that worked on that is working very closely with us on our DSC Graph. It came from Aurelius, and they took to market Titan, and they just announced Titan 1.0. So Titan 1.0 is very, very similar. It's not the same thing. We're not forking Titan, and that's going to stay as an open source project. We're going to take to market a brand new graph offering for you as part of DataStax. So you have this multi-model option. And it's going to be built upon the idea of a scale-out graph. It's meant to be a scale-based graph implementation, OLTP graph, if you will, so that you can model your data using the modeling language within which is essentially going to be Gremlin. I'll introduce that to you in a second. The ability to store billions of entities within that graph, to be able to traverse those, walk those. And the whole idea is if you have a complex data model that's based on relationships, it has a lot of ideas behind it where you actually are almost thinking of yourself as walking that data model, going up and down, traversing through the data. That's why we have a separate query language that is called Gremlin that is built specifically for that purpose. And that is an open source, sort of a standard query language for graphs that so we are going to continue within DataStax to maintain that as an open source project. And then because it's DataStax Enterprise, you get the all the goodness that comes along with the DataStax Enterprise in your graph model as well. So I do want to just kind of put one thing out, that the way that we're approaching this from the way we're building graph for DataStax is that it wouldn't be a matter of you have an existing Cassandra app and then you would just apply a graph onto that. These are separate data models, right? They will all be materialized within Cassandra, but they will be separate models. You need to model your data separately. But the idea behind that is that if you want to do some things, like if you want to do page rank, or you have sort of complex analytical requirements for your app, you may want to put some of that data into a graph model, and you can also leverage Spark with that. This is actually highlighting the integrations that we have with DataStax with Spark and with Solar for search. And the way that that works is all integrated within our graph server capabilities, so that if you have a query that is needing to pull back a large portion of that graph, instead of just looking at one single vertex and looking at the edges off of that, if you need to traverse an entire graph, we can execute that in a separate Spark context and be able to bring back large aggregated bulk style analytics for you from your graph. And you won't need to go through some kind of complex wiring up of that. That's going to be something that we give you out of the box. In addition to that, the Solar integration is going to be there for you. So if you are searching for all of the people that are related to your friend who have the name Mark in it, or let's just say have start with NA, and you can do sort of full text index style searches across that graph by leveraging a Solar index on that as well. So that's all going to be part of the offering for DC Graph, and this is our vision. So what would fit well within that model versus a CQL standard Cassandra model? A couple of examples. I only put two in here. There's a lot more, but these are the ones that, as I go around talking to customers, as a product manager, I talk to customers all the time, and sort of trying to understand what's the best fit model for graph. And the reason why I need to know that is because if we're going to build a multi-model, we're going to go to market with a multi-model solution, we need to know what are the use cases that you're going to use to model your data as a graph. And this is an interesting one that comes up a lot, which is the idea of gathering a lot of different data across an enterprise that gives you that 360 view of the customer. It's kind of it's a very marketing kind of term that's out there, and a lot of different things fall into it, which is why I like to use it. So one of them is essentially the idea of having a solution that's a master data solution, giving you a single source of truth. The ability to get that view of your customer, not just on what they're buying, so think of something like maybe CRM, maybe also, you're collecting information about purchases, so POS systems, but also the ability to combine that then with socials, so you can get that immediate feedback of what they're saying about your product. Now, when you build that as a graph, the nice thing about that is we're building a property graph based on what the folks at Titan did. So that can allow you to think about these things. That can allow you to put on those relationships between product and customer and when they bought it, put weighting on that. So now you're not just looking for, thank you, you're not just looking for when things were bought and what did they buy, but you can put weights on the different attributes that you want to adjust on the fly of what gives you something like a recommendation, or what gives you something like you need to look at inventory levels on that. So that's the idea of Customer 360. Another one that's very important that kind of goes across a lot of our customers is this idea of network and IT device impacted.
Okay, so you're saying enterprise access management, right, which almost
Yeah.
every enterprise has, but that has to be very consistent. Is this gonna be consistent? Because that, that drives people's access.
Explain what you mean by consistent.
Well, so we have the plumbing for that. We run it on Oracle.
Okay.
And so, if you wanna see the CEO's reports, right, it'll run against this distributed system that we built in-house that is tied to Active Directory, that has a huge, even greater tree than Active Directory about what your accesses are.
Yeah, right.
And so is this suitable for that? Because it runs on Oracle today, right, which is completely ACID compliant.
Oh, you're talking about that, that's consistent. Okay, I got you, yeah. So I'll put it to you this way, what we're doing with Graph is providing a little bit more level of consistency than what you get out of basically the way most people configure Cassandra today. There is a locking mechanism that is available to you within the Graph database, because the idea is that because that's a common use case, and those sort of use cases that people use Graph for, the folks from Titan have realized over the years they needed to do that, because they had issues with eventually consistent databases. Remember, Titan, if you're familiar with Titan, it has multiple different backends that can be used with it. Cassandra is just one offering for it. And with to provide that level of consistency, there was mechanisms built into it that we're going to take over with it, with DSC Graph, that will provide you some of that.
And you're gonna see better consistency levels in the future.
For the graph, well, the graph
For the
will be, the graph will have a different sort of set of mechanisms for that. A different query, it's going to have a query optimizer, query rewrite capabilities, locking capabilities, and those things. You'll see it. And we're putting that documentation in place right now. It's not all, because we're not in market yet, it's not there yet. But we will describe that architecture
That's awesome.
for your white papers as we get closer to release.
Two questions. So one is, where is the line between, let's say, execution engine like Spark versus, the logical view of the data as a graph, right?
All right, good to wrap up.
1 more minute.
Okay, I'm sorry. I didn't know if I take offline or. Where's the line between the execution engine of Spark and, I'm sorry, you were saying?
And the logical view of the graph data.
So there's a couple of things that, just speaking generally about Spark with the way that we're approaching Graph, is that, think about it this way, at the end of the day, all the data that is being persisted within the Graph is going to be in the same key space. So we have customers that are probably going to go over there and going to do things directly against that data. The Spark execution engine for Gremlin is going to be based upon different heuristics that we have built into that optimizer to say that this is a large query that I need to bring back 3/4 of the graph because I need to traverse, aggregate, count, sum. So that's going to get sent off in an execution engine, in a Spark RDB essentially.
Or take a
Spark
middle
context.
tier. Like Spark is just like one flavor of a middle tier, right? Like an execution environment. The second question, do you look for the relationships out of the data, or how does the graph get complete?
That's a trick question. So the graph is created by many different mechanisms, right? You could bulk load it, you could, I'm just kind of coming over to that. You could bulk load it, you could run it, kind of a trickle feed kind of scenario, you could load it from your application, all kinds of different ways. But no, there is not, I know I'm out of time, there is not sort of a way to automatically infer. We have users who use Titan today that use different algorithms to use things like a JSON underscore